Hi, everyone. My name is Kyle Sword,
And I'm Kayla Natividad.
and we're here today. We're doing a product presentation on our NSG TEC. So the idea on these presentations isn't to be all-encompassing, AIA approved. You know, you spend an hour in very nondescript terms talking about the product generality. This is more for in-house and for customers. And what we really want to try and do is dive into the specifics on the product. So what is it? How does it work? How does it compare to other stuff in the field? Where would you use it? You know, what products do we have? What are our branding? And then is there anything else? And what I'll try and tell you on this is I know enough about these products to be dangerous, and Kayla is actually the technical expert that we have. So she's here to keep me honest and hopefully steer me in the right direction if I get off course.
You're too
Um,
kind.
Anytime, Kayla. So the way to think about our tech product is more to think about it like you would a conductor. So just the way that a wire transmits electricity from one point to another, our tech product is an invisible transparent coating that transfers wire electricity from one point to another for a variety of different sources. So, you know, stop thinking about the product as you would a glass and start thinking about it more the same way you would about a wire product. And it's what's called a TCO, a transparent conductive oxide on glass. And I'll talk a little bit more about the families of this, but a TCO is kind of the family, and then one product that's within that is FTO, fluorine doped tin oxide. So that's the type of coating that we put down. Our Tech 15 is going to end up being about 15 ohms per square after you temper the glass. And we make products that are somewhere between 6 and 1,000 ohms per square. Now that per square is per square inch, per square mile, per square foot. The resistivity that goes across there really doesn't change based on the area. So you're talking about sheet resistivity, but the glass then becomes the wire, and essentially our product becomes a technology enabler. So we can enable all these other sorts of different technologies based on this. And we're going to talk a little bit in depth on this picture that's on the bottom right. But Ohm's law is really important for what we're talking about. And that's the relationship. Again, I'm not an electrician by any stretch, but that's the relationship between power and voltage and sheet resistance. And there's all sorts of different ways that you can play that out. But the key things that when we talk about our product is how much sheet resistance is there. So what are the ohms per square? And that's how much power loss and how much heat gets generated in an area. You talk about how many amps get used in the usage of the product, because that's how much draw you have on your power, and that is how much you're going to end up paying to run the thing. You talk about power density, how many watts per square meter that the unit ends up consuming, and that will tell you basically how much heat it's going to generate and how quickly it's going to warm up. We talk a lot about haze, so how cloudy is that product as a result of our making it. And then we talk a lot about glass aesthetics. And Kayla, you brought up the point about how we still need to think about this as a glass product.
Yeah, so a lot of times when you think about wires and whatnot, you look at any electronic and your wire isn't actually seen, right? It's hidden in the plasticky, bulky part of whatever it's in. But for a lot of the products that we sell into, part of the reason they're using our product is because they want an aesthetically pleasing, transparent product, right? And so not only do we have to take all of these um, circuitry and electrical components into consideration, but we also still have to keep our good aesthetics, whether it's from our base glass or from uniform color or honestly just keeping a uniform sheet resistance through our process. And so that's just another factor that we have to take into consideration whenever we're going through and making our product specifically. It's combining your architectural world and your electronics world into one product.
Awesome. Yeah, thank you, Kayla. So, you know, Tech Glass has been around for a long time. I mean, people in the commercial refrigeration industry is probably our biggest consumer, and that's been happening for 20 or 30 years. And you probably don't realize this, but almost every grocery store you go into, the cooler section or the freezer section, you know, they're using our tech product to actually heat the glass up a little bit. And that's so that the glass doesn't frost up. You're trying to heat it above the dew point. And you think, well, why would you heat a refrigerator or a freezer door? Well, the reason is they want to keep the glass above the dew point so the glass doesn't frost up. And that's because the grocery store wants you to see through the glass and see what's behind there and buy more microwave pizzas and ice cream. They don't, you know, they don't care about that extra nickel that they're spending in power a day. They want to sell $100 more worth of stuff that's in those freezer cases. So it's been used for quite a long time. And Kayla, any comments on commercial refrigeration?
Yeah, so generally the way condensation builds up on the glass surface itself is it has to do with the air temperature, the temperature of the substrate, and however much moisture is in there. And so really what you need is just a really good insulator, I guess, if you really want to keep that from happening. So you don't want the warm exterior um, temperature of whatever room it's in, and then the cold temperature. What if it's too warm and too cold, and it's meeting on the surface of that glass, then you end up. That's when you get that condensation. Think about like a sweating cup almost, right? And so what using this coating allows is instead of requiring um, really great thermal properties from just a static product, you're able to control what the temperature of that surface would be specifically. So that's part of why it's such a great product for refrigeration.
Okay, awesome. Well, thanks, Kayla. So it's been around a long time. And again, we don't make just one tech product. We make 20 different tech products between 6 and 1,000 ohms. And one of the reasons why is because of this. So when a commercial refrigeration company is designing a door, they have, say, a 3 foot wide by 5 foot tall door, 6 foot tall door. They're going to figure out what power density they want to give that glass enough heat to heat it up a couple degrees to get it above the dew point. And that a lot of times ends up being your power density. So in a 36 by 72 inch using Tech 15 with 110-volt power, that's going to give you a power density of about 268 watts per square meter. It's going to pull almost 4 amps, and it's going to use about 430 watts of power. So if that same company then says, well, I want to make a smaller refrigerator, I want to make a 36 by 36 inch one. If they use the same tech glass, now look at the power density. They're pulling a lot more power. They're using, the power density is about 1,000 watts. So it's going to heat it up a lot more. It's going to get warmer. It's going to defrost it quicker, but it's also going to consume a lot more power. So instead of doing that, what they could change this and say, we'll still use Tech 15, but we'll use inverters to get the power down so we don't burn quite as much. But if they just change out the glass and they start using a Tech 70, Tech 70's got a different sheet resistance. So that sheet resistance with the same sort of power voltage, instead is only going to have a power density of 225 watts per square meter, and it's actually going to use less amps and less watts for that usage. So their net refrigerator uses less power, but gets the same amount of defrosting out of it. So they might just as easily say, well, we'll just use a different tech product to get the sort of heating level that we want to do the defrosting that we want. That's what drives a lot of the customization in our products. So the other thing to think about is, again, all other things being aside, a higher sheet resistance typically means you're going to use less power on that design. And so as commercial refrigeration companies want to use less and less power, they may be moving to higher and higher ohm sheet resistance products. And Kayla, feel free to jump in on anything you have here.
Oh no, I think you explained that beautifully.
All right, awesome. Other options in this field, people might use the thing called indium doped tin oxide. And again, TCO is the family, and then there's a couple different products. ITOs tend to be sputtered products. Instead of sputtering a silver, you sputter an indium on there. These are generally really good products on a really low sheet resistance or really low conductance. So 1 to 5 ohm per square sheet resistance. They're generally pretty expensive, and they're generally really, really low haze product, 0.1, like almost no haze. So they look really good. They do a great job of heating up in a lot of power. But in places where that little bit of haze and you want a higher sheet resistance is, that isn't really where you would want to use an ITO. You probably want to more use our product. So in a super high performance, super low sheet resistance products, ITOs might be specified in some like electronic products. But as you drift out of that 1 to 5 range, we tend to have a better value proposition for a lot of places. The other thing that we might be competing against in certain applications can actually be wires. So if you think about the back windshield of your car, that tends to be wires that are just run from the battery, and you're literally just heating the glass up using wires. Or you can also get like these little heating pads and stick on it, like the mirror that's on the wing mirror of your vehicle is literally just a little heating pad that goes on the side of it. So those, if it doesn't affect the aesthetics and you're okay with that, those might be good solutions, better cost, easier to heat, more power through them. But as you get different options and alternatives, like in cars especially, the power voltage in a vehicle, a 12-volt battery, just isn't enough to run our tech to heat it up well enough. But as you get into electric vehicles, I actually think that's going to change. I think you're going to start seeing people use our tech product to heat up the windows so you get rid of that big wire mesh that goes across the back of the vehicle. And that's just one application. The other thing that you see as a possible application is any place that you use the glass as a wire and you want to conduct power into or out of a unit, you can actually use the tech as a transparent product that actually drives that technology. So one of the places that we see this is with LED glass. So you think about LEDs, this picture in the top middle, these are LEDs. So these are little RBG, I don't remember which it is, but it's red, blue, green. And you use those little pixels to generate light in hundreds of thousands of different colors by combinations. But this is what a wiring diagram looks like on a lot of these LEDs. There's millions of wires that stick in the back of them. So the back is kind of a hot mess. So what we're actually seeing people start to do is use the tech glass, etch patterns into it, and then use that to conduct the power to the little LED parts. So now essentially what you're doing is you're making an LED where all the wiring is fully transparent. So you can embed that LED right into glass. And this is an example of what one of our customers is doing with this technology. So the entire facade has these little LEDs embedded every inch. The tech is in this wild configuration that drives power to those, and then you use a computer to turn those LEDs on and on. And this is the same building, just at different times a day, or different scenes. This could be 10 seconds apart, 5 seconds apart. You can run a movie on the facade. The entire facade ends up then becoming your technology, and it drives these different technologies. Any points on this one,
Yeah.
Kayla?
Just something to note is if you actually look at the building, up on the right side of that image where like the white and red lines meet, you could see the lights that are turned on inside of the building. And so what you're that's a good example of showing that it is a fully transparent product, right? So essentially, whatever you're seeing on the outside, people are also seeing on the inside in a reverse image. And it's in applications like these where when you go through, you don't want your any wiring connecting the LEDs because again, it's just an obstruction of view from whatever's occurring in the building to seeing the outside. So.
Right. And when this display's off, it just looks like a frit pattern. You literally have a little black dot like every inch. So you can look out the window and it looks great, even with the displays off. You just have this little frit pattern that you notice. The other thing we're seeing people start to do is enable like different types of technology. So thermochromic paint or electroluminescent paint. This is a paint that when you drive a current into it or heat it up, it actually starts to glow or change colors. So again, just think about the tech as the technology enabler. Anything that needs power to drive it, and you want to do that transparently, you can actually use this technology to do it. The other thing you can do is if you think about using two pieces of tech in a design, now essentially you can have a positive terminal and a negative terminal like you'd have in a battery or an anode cathode, and you're actually driving any sort of technology that you want in between there that would change with a voltage switch. So you think about switchable technology, electrochromic technology, battery cells, BIPV, all these different things where you're trying to change the state and using a couple pieces of conductive material, you can really enable those technologies using our tech glass. So one place that we see this done is with touch screens. So essentially, if you take one piece of glass, you make a vertical grid, the other piece of glass make a horizontal grid. You can now use that to, like X, Y, sense where your finger is and use that as a touch screen kind of enabler. So that's one way people can make touch screens. We also see this get used in a dynamic, electrochromic and switchable glazing. So this is from one of our customers, and what they're doing is they have a material that's inside, and this can be liquid crystal, it can be different types of materials, but all you're doing is you're changing the state or the polarization of what's inside there with a voltage change. And this is essentially what you're seeing is you might want that to darken, or you might want it to go opaque, or you might want it to do a number of different things. And what this customer is doing is they actually switch this and they're making it darker. It does make the window more energy efficient by lowering the SHGC and making it a better insulator. But really what it does is it adds so much value to the rest of the room because you're not dealing with all this excess sunlight and brightness. You don't have all this excess heat coming in. The space becomes more usable. And that's really what's selling these technologies. There's some great examples of where this is being deployed in airports, like where the seating area is by the gate. It just gets too hot to sit by the windows. Lots of really great case studies. And Kayla, you probably have a lot more information on this.
Yeah, and like really another thing that just from an aesthetic standpoint that you might want to take into consideration is even looking behind us and you see all of these blinds here. And half of them are open, half of them are closed. If you're on the outside of a building and you look at, and you're looking up at it and seeing this effect, a lot of times it's called the gap tooth effect, right? It literally looks like the building is missing teeth in a sense. And so doing this really helps your building aesthetics. Just not having to worry about the ununiform look from the outside.
Yeah, excellent point, Kayla. And again, this is what one of the views looks like when you're installed. These have been switched. They're a little bit darker. You can get daylight in the upper areas where people aren't sitting, but it's a really nice product that really drives a lot of different technologies. The last thing you can use our tech product for is actually driving a lot of different solar cell technologies. And this could be, any number of technologies. This picture on the right here, this is just one thin film voltaic, but there's a number of different coating technologies where you need to have some sort of TCO material in there. You need to have some sort of backplate, but you either use the tech technology to actually help drive the CAD-TEL or the PV cell, or to get the electricity out once you generate it. So it can be used a couple different ways, but really it becomes an integral part of that design and that stack on how you build a solar cell. So that's it. Kayla, anything else to add?
Nope. Thanks for putting this together. Genius as always.
Awesome. Thanks, Kayla. Hopefully this has been helpful. If you have anything, other questions or need anything help, we're always happy to help and love new and interesting ideas. So thanks again, and have a great week.
Have a good one.